Alright, I'm hoping that this works. Alright, just some individual chain rule problems for people that need some extra help. We'll start off with an easy chain rule. We'll build up to chain rules with product rules, and hopefully make this no longer than like maybe 8 to 12 minutes. Okay, I'm going to do this one the long drawn out way. I'm going to let u represent the innermost function, which is 9 minus x squared. Therefore, f of u is going to be equal to u to the 2/3. So if I do f prime of u times u prime, so I'm going to take the derivative of this function, which is 2/3 u to the negative 1/3, times u prime, so that's going to be the derivative of this piece. So that's just going to be a negative 2x, and f prime of x then is going to be equal to 2/3, substitute u back in, which is 9 minus x squared. Hey. Resume. Okay, on to the negative 1/3 times negative 2x. And the last thing I want to do is just simplify this. So the numerator, it looks like I'd have a negative 4x, and the denominator I'd have 3. I'll just write it as the cube root of 9 minus x squared. And there's f prime of x. Now that's the long symbolic way to do it. The faster way for f prime of x would just be bring the 2/3 out in front. Don't touch what's inside the parentheses, subtract 1 from the exponent, and now take the derivative of the inside, which is negative 2x. And I'm not going to simplify that, but as you can see, it ends up being the same thing. Okay, now let's get to ones that are a little bit harder. Let's see the next two here. Of these two, I'll do this first one. So this is a product rule with the chain rule. So we're going to write y equals x. We write this as 1 minus x squared to the 1/2. So the derivative of the first times the second. Now it's the derivative of the second, which is this, is a chain rule. So bring the half out in front, leave the inside alone, subtract 1 from the exponent, and then times the derivative of the inside, which is a negative 2x. Alright, it's y prime. Alright, let's simplify this a little bit before I factor. So this should be a plus right there, right? And then a plus. So what do I have here? That and that cancel out. So, and that's also going to become negative in there. So a negative x squared times 1 minus x squared to the negative 1/2. Alright, so the greatest common factor is a 1 minus x squared to the negative 1/2. Take the lower fractional exponent. Alright, so now when I divide, this divided by this, I'm going to subtract the exponents. So it'll be 1/2 minus a negative 1/2, which would be to the first. So I'm going to have a 1 minus x squared, that to the first, and then minus, and if you want to put it in parentheses, you put it in parentheses. An x squared divided by 1 is just an x squared. And now when I do this divided by this, subtract the exponents is going to be to the 0 power, which is just a 1. Anything to the 0 power is 1. And now let's do a little simplification here. This is going to be the square root of 1 minus x squared. That's this piece going to the denominator. Inside here, I get a negative 2x squared plus 1. And then there is your y prime. Okay? The second one, kind of the same thing, just a quotient rule. I'm not going to do the quotient rule. I'll do this one. This one's a little bit more complicated. Actually, hold on a second. Let's do this one. I'll skip that one too. Okay, so I'm going to rewrite this first as 8x to the 1/2 times 2x minus 1 to the 4th. So it looks like I have a product rule with a chain rule in both of those. So the derivative of the first is going to be a 1/2 8x to the negative 1/2 times 8. All right, the derivative of the first, yes. And then times the second, which is going to be a 2x minus 1 to the fourth. So this part right here is the chain rule of the first part. And then plus the first. Now the derivative of the second, this one's a little bit easier. It's just going to be a 4. Leave the inside alone. Subtract 1 from the exponent times the derivative of the inside. All right, and this will be the chain rule of the second part. Okay, so let's simplify this. This is going to be a 4 times 8x to the negative 1/2 times 2x minus 1 to the fourth plus 2 times a 4 is going to be another 8 times 8x to the 1/2 times 2x minus 1 cubed. All right, and the greatest common factor between 4 and 8 is a 4. Between the 8x to the negative 1/2 and that to the positive 1/2, it's going to be an 8x to the negative 1/2. And then a 2x minus 1 cubed. And now I'm going to divide. So 4 divided by 4 simplifies out. 8x, that's going to simplify out to be the 0 power, and I'm left with a 2x minus 1 to the first. Plus 8 divided by 4 is a 2. An 8x to the 1/2 and an 8x to the negative 1/2. Subtract the exponents. So that's going to be an 8x to the first. And then the 2x minus 1 cubed, these two simplify out. Alright, so let's see. Denominator, square root of 8x. Numerator, I have a 4. I have a 2x minus 1 cubed. And in here, it looks like I have a 2x minus 1 plus a 16x, which is plus, oops, sorry, times 18x minus 1. And I guess we could simplify that a little bit further, because this is 2 root 2, right? So 4 over 2x minus 1 cubed times 18x minus 1 all over 2 root 2x, and that can cancel out with that, and that'd be a 2. So that'd be a y prime. Okay. And last one. Chain rule with trig. Alright, so the chain rule with trig. One sec. Okay, so I'm going to rewrite this as y equals secant x squared cubed. So the derivative is 3, leave the inside alone, to the second. Now times the derivative of secant, which is secant, leave that alone, tangent, leave that alone. So the derivative of secant is secant tangent with the x squareds, and then times the derivative of x squared is 2x. Alright, so let's see what I get here. That's going to give me a 6x, a secant squared x squared times a secant x squared tangent x squared. I can combine those two, multiply them, get a 6x secant cubed x squared tangent x squared. Yeah, you just got to be really careful with this one with the x squareds and the secant squared. All right, and there's y prime. All right, hope that helped. Hope you could stop it in where you need and watch it and listen and watch it again if need be. You can ask me any or comment on this if you want via email or in class at any time. Hope it helped.